Today's lesson, let's look at our schedule. I passed out new versions of the schedule due to the snow day. Everything just got pushed back, including take-home quiz 1, right? I was supposed to give it to you on Monday. We didn't have class. It was posted on Moodle, so I saw some of you have done it already. You can either put it in the folder if you're confident that it's ready, or you can hold it till Friday. Okay, so I will pass that out before you leave today. Make sure you don't leave without getting a copy of it. And again, it's in Moodle, so if you lose it, you can print another copy. And then, so I'll hand you that before you leave today, and it'll be due Friday. It's due the following class. And then other things that are coming up, just test 1 is going to be the 22nd, got pushed from the 19th. So everything got pushed today, including homework assignments. So if you go into my math lab, you'll see that all the dates have been pushed. Okay, so people are doing pretty well with the preview exercises. I'm going to jump to the demo. We're going to continue talking about modeling with equations today. Okay. So the examples that we've worked with so far have been solved using one linear equation and one variable, or can be. Some of you were using 2 variables last class already, which is great, because that's what we're going to work on today. Okay. We're going to create and solve systems of linear equations in 2 variables, or a linear system. So this graph represents the system of linear equations x plus 2y equals 142, and negative 3x plus 10y equals 160. So the equation negative 3x plus 10y equals 160 models the percentage of never married U.S. adults, and the equation x plus 2y equals 142 models the percentage of married adults. So I want to estimate the coordinates of the common solution, the intersection point of these 2 lines. What's it look like? Yeah, what are the coordinates? 6838, sure. It's an estimate because it's not right on a grid mark, so we have to estimate a little bit. What does that tell us? What does the 68 mean? What does the 38 mean? Mm-hmm. Will be the same, both at 38%. Good. So 38 years after 1970, that's 2008. So in 2008, the percentage of married and never married adults will be equal at 38% each. Why doesn't it add up to 100%? Yep, divorcees. Yep. So never married versus married are, there is another class of people who have been married but are no longer, right? So that's why it doesn't add up to 100%. No, because we're measuring X in years since 1970. Oh, 60, you're right. I added 38, which was the Y coordinate. Thank you. Yeah, I gotta add 68 to 1970, which is 2038. Thank you. All right, so the solution to a system of linear equations can be found visually by graphing, which you did in the preview exercise. We just did here in this example. And we're also going to review 2 algebraic methods, substitution and addition, also called elimination, that allow us to find the exact solution for a system of linear equations with 2 variables. So here's an example system. X plus 2y equals 142, negative 3x plus 10y equals 160. That's the same. Those are the equations that we used in this model for married and never married. Okay. And I want to solve this system algebraically. So first we'll do substitution. Typically in substitution, you start with the easier looking equation. Which one looks a little simpler to you? The top one, okay? So we start with x plus 2y equals 142. And then you solve for one of the variables, right? Whichever one you want, typically whichever one would be easier to solve for. Which one looks the easiest to solve for? X, because it has no coefficient on it. So I can solve for x in one step by just subtracting 2y from both sides. So x is 142 minus 2y. It's completely a choice which variable you solve for. Typically, you just pick the easier one. All right, once you have a variable solved for, then you write down your other equation, negative 3x plus 10y equals 160. And then you recopy this whole equation, but instead, anywhere you see an x, you're going to replace it. Oh, right. Anywhere you see an x, you're going to replace it with the expression that x equals. Okay? You substitute it because they are equal. They're the same. So I'm going to copy this equation. I'm going to have negative 3. Instead of an x, I'm going to put 142 minus 2y. Make sure you do parentheses because you're doing negative 3 times that whole expression. Then plus the 10y equals 160. Now you have an equation with just one unknown in it, and we should be able to solve this. We'll distribute the negative 3. I'm going to need a calculator here. 436. 426. Thank you. Plus 6y plus 10y equals 160. I'm going to add 426 to both sides, so it's going to be 586 equals 16y. Divide by 16. 36.625. Is that close to our estimate that we got graphically? What was our estimate graphically? 38. Yeah, so that's pretty decent. Yeah, it's pretty good. Pretty good guess. And let's figure out x now. Go back to your other equation. If you want to get x, we just do 142 minus 2. Now we know y is 36.625. So we get x is 142 minus 2 times 36.625. 68.75. And that's also close to our guess, which was just 68. So we did pretty good with our guesses. So is this familiar? Substitution method? Looks, done it before? Good. All right, let's look at another method. So we've got two methods now because we can estimate graphically by looking at where the two lines cross. We can solve by substitution. And now we're going to do one more solving by either, it's called addition or elimination. So I'm going to write down both equations here. X plus 2y equals 142. And negative 3x plus 10y equals 160. And I have to pick a variable to get rid of, right? Which variable would you like to get rid of? X? Okay. So my goal is that I'm going to add these two equations together, or some version of these two equations together. And when I add them together, I'd like the x term, this x term, and this x term to add up to 0 x's, right? So if I have negative 3 x's on this second equation, how many x's would I want in the first equation so that when I add them, I get 0? 3. Okay. Just 3 because I have negative 3 here. Yeah, and I'm going to add them. Yeah. So what I'm going to do is I'm going to multiply the entire first equation by 3. And then I'm going to rewrite my two equations. So my first equation is going to become 3x plus 6y equals 426. And then my next equation, I'm not going to do anything. I'm just going to rewrite it underneath this one. Negative 3x plus 10y equals 160. Then I'm going to add those two equations together. 3x plus negative 3x is 0 x's. The x's just drop out. 6y plus 10y is 16y. And then here I get 586. Divide both sides by 16, so y has to be 36.625. And then you can get the x by substitution. Okay. You can pick either equation, does not matter which one. Any equation that has both x's and y's in it, replace the y with 36.625 and solve for x. The altered equation would work also. Yep. Any equation that has both x's and y's in it. Yep. So I just randomly picked an equation. I replaced the y with a 36.625, and when you solve for x, you should get 68.75. So does this method also look familiar? Like you've at least seen it before at some point? Yeah? Okay, good. So you have two algebraic methods, substitution and addition, which is also called elimination, and you've got a graphical method. Look for the intersection point. All right, so we're going to do a slightly trickier word problem than we looked at last class, a dual investment problem. A scholarship fund has $10,000 in it. We can invest in two different funds. One's low risk and one's higher risk. From the lower risk fund, we can expect to earn 4% annually, and from the higher risk fund, 8% annually. We want to have an expected return of $550 a year, because maybe that's the amount of the scholarship that we give out. We give out $550 every year. So we want to take our $10,000, invest it with as little money in the high risk fund as possible, and get our $550 to give out a scholarship every year. So how much money do we put in each fund? All right. So some students find tables helpful for setting these kinds of problems up. So like I explained or pointed out last class, start by identifying the question. How much should we invest in each fund? So there's two different funds, right? So I'm looking for two different numbers. So we don't know what they are. Let's call them X and Y. Okay, so let's have X be the amount in the low rate fund, and Y will be the amount in the high rate fund. So the amount we're investing in the lower rate, don't know. In the higher rate, don't know. That's what they're asking me to find out. So I put X and Y in the chart. How much total am I investing here? $10,000. So I put that in the bottom of the chart here for total. The percent interest for my lower rate is 4%. Put that in as a decimal. And then my higher rate gets 8%. Put that in as a decimal. And then the way you calculate interest on an investment is you multiply the interest rate times the amount you invested. Right? So I just do the amount invested X times my interest rate 0.04, and I get 0.04X. My higher rate, the amount of interest I make, is 8% of Y. And then what do I want my total amount of interest to be? $550. So it can be helpful to organize all the given information into a table. You don't have to. If you can write an equation without doing that, it's fine. Once you have all this information organized into a table, then you have to ask yourself, okay, what equals what? And I'm going to need how many equations here? 2, because I used 2 unknowns, I need 2 equations. So I have to look at this table for relationships. What equals what? So x plus y should be 10,000. The total amount you invested is 10,000. You put some of it in a lower rate, some of it in a higher rate. All together, we get $10,000. Can anybody see another equation, another relationship in this table? Yeah. Yep. Yep. Yeah, the interest earned on one of your accounts plus the interest earned on the other account has to add up to a total of $550 interest earned. And then you can solve this using your favorite method, substitution, elimination. Let's do it quickly with substitution. I'm just going to solve this first equation for y. So I get 10,000 minus x. Then I go over to my other equation, and whenever I see a y, I'm going to replace it with a 10,000 minus x. And now I have an equation that only has x's in it, so I should be able to solve this. So 8% of 10,000 should be 800. Anybody know how to do that in your head without a calculator? Right? Well, you can do, what's 10% of 10,000? 1,000. You move the decimal 1 to the left, right? So if you move it 1 more to the left, what percentage is that? 1%. So you can quickly find 1% by just moving the decimal 2 to the left. You don't have to know how to do this in your head. It's just a fun little lesson. So 1% of 1,000 is $100. And then if you want 8%, just multiply it by 8 and you get 800. All right, so I have 0.04x plus 800 minus 0.08x equals 550. I'm going to combine my like terms on the left. 0.04 minus 0.08 is negative 0.04x. And then I'm going to move my 800 over, subtract 800 from both sides. So 550 minus 800 would be 250, negative 250. And then divide both sides by negative 0.04, and we get x is 250 divided by 0.04, 6250, $6,250. So that's how much money we're going to invest at the lower rate. And then at the higher rate will be the rest of our money. 10,000 minus 6,250. What? $3,750. So my lower rate, 6,250. Higher rate, 3,750. Okay, so that's it for the lecture part of class. You're going to be solving systems of equations involving word problems that involve systems of equations. Just call me over if you have questions.